Welcome to the next episode of writing an image converter in Rust. Thanks for stopping by. Last time when we finished, we were trying to get the renderer to just have a red image, and we were making the points to display them on the screen. And in this episode we hopefully get to actually display the points, as well as doing some form of blurring. But if we get the points done, maybe we can do the blurring in another episode. Yeah. So currently we load the files. We get the image bbox from the XML file. We make we can write a BMP file. We were trying to get the uniforms working. So we tried in the draw method. Yeah, we have to say that these are F32 parameters. I think that's the issue. I hope it is. Yeah. And we will need, these are the dimensions of the area that we're currently looking at. And we will actually need these dimensions in order to make this a bit more clean, this data loading. We will just write a function load data, which will modify the app window. So this is not in any functional way, but I think it's more clean than having the data loading shared across separate files. Yes. So because we need the vertex buffer, we will also need the index buffer. Which will be an index buffer of U32. We will later on explore which types we exactly need from this image buffer, and so on, as well as the texture, which is a it should be in another struct. And the texture is a width and a height. And the actual data is just a vec of the 8 characters. So texture yeah. So we first need to get the app window to load, and then before we show the app window, we can actually load the data. So in this data loading function, we simply take out and this is generally my approach to making things a bit more fault tolerant. Just have it as an optional type and not required, so that we can say if the data is loaded, then we can load it in a separate step. And here we will just pass in none because we don't have any data yet, but we already have the shader, we already have the other stuff. So we will put all of this stuff, all of these functions, probably in a separate file. So to do this, we can just open separate file. We just put all of these functions. We put the load files. Put the load files in there. We put the other function. In there. And this is way easier to restructure if you write this in a bit more functional way. Because now we can just take the functions, take them out, put them in another file, and that's it. Right. And then we can do this. We will do it like this. Put this function into the renderer. And then put this function also into the renderer. Right, and now we can just take this out and save and open the data file, and then just say, okay, we will have these types. So everything that we have here, always put the macro use things first. Yeah, so everything that we want to do actually is to say we want to have a window and then before we open this file, we just say we want to load the data of this test box, and then we loop, and all of this functionality is going to be in the data file, and the actual data loading and iterating is, well, it's currently going to be in the well, do we want to, no, we want to let all of this be in the actual we want all of this up until here to be we want all of this to be in the main function. This should be in the window load data function, because we can take this out later, but we actually don't want to do it yet. So this is where we currently are. We load the data, and then we say, okay, at the end of the function, we say that we want to make a buffer, but this is just the pubmod data and renderer window, and yeah, this is basically the whole magic. We can say, okay, new load data, and we can say loads the data. Then we of course need to have a bounding box, bbox, bbox, so loads the data into the renderer. So this way the whole program is basically, we put the bbox, we create the bbox, then we say, okay, we don't need this anymore. We just create an empty window, and then we load the data, and then we show the window. So so this will probably not compile because we have loads and loads of errors now. So we'll just try. So this bbox, let's just make all of this public because there's no reason to have it private. Yeah, don't judge my English. It's not the best, but I'm trying. Render, right. Use render. No, wait, what file is this? We don't need this anymore because we have now imported this. Ich versuche im Stream Englisch zu sprechen, okay? Tut mir leid, tut mir leid. So I'm just trying to practice a bit. So fs file create, no module fs. Yeah, we basically need to fix all of the imports. Use standard fs. Right. Next. We don't have an index buffer. Yes. Beyond frame. So basically we'll make multi-import surface program vertex buffer index buffer. Right. And then we can just delete all of this. And next. So we served a display. Yeah. Reference to served a display. Points. There are no points. Sure. We actually have the load the data into the window. Self dot, what did I call this? Self dot, well, yeah, I'm sorry for the keyboard. Yes, it's mechanical, but it's not a high quality one, so I'm really sorry. Well, yeah, I could use, well, I don't have my other keyboard right now. Data is an option of app data. So we have an optional app data. If we create the window, we can say app data none. Yeah, just so to stay consistent. App data, vertex buffer, index buffer, texture. Right now we just say, okay, this index buffer is optional. Index buffer is optional, so we then say if we load the data, then self.app data equals sum, and then app data. In this app data, we need to say, okay, vertex buffer, vertex buffer is the vertex buffer that we created up here. Vertex buffer, and let's just say the index buffer is none, texture is none. Right. Vertex buffer. Since we only load one file, this might be okay. We probably need to move this out later on, but shouldn't be too difficult. Vertex buffer equals make runner points. Yeah, we don't have any points anymore, so we need to load the points. We need to load the points. How did we load the points? How did we load the points? Maybe in the renderer? Oh no, we yeah, great. Yes. Oh boy, I'm not very good with Emacs. Right, we had the load files method in the window load data. So to load the data, we say add files equals load files. And then the problem is that we said, okay, here we have the renword generate points method, and that's where we get our points from. And here games are not, well, I do have some. Do I have Steam? No, I don't have Steam. I can probably show you what games. There are some games that do run, like Tomb Raider does run. Some of my favorite games do not run, so it's a bit tricky. If you just play like Civilization or some sort of things, it can be okay, but it depends. I don't play a lot of games anymore because most of the time I'm just considered with working, and if I play games I can always boot to Windows, so it's not a big deal. But for things like performance debugging and some programming related things, Linux is a bit more convenient. So I just use whatever the best option is. Right, so can no, you didn't indent the read. Fuck. So here we have our vertex buffer, then we need our points. We need our points, which basically says, okay, let midpoints equals back. We just create a new vector here, and then we just say, okay, we have loaded the points here. Then say let points equals this, and then we can say, okay, right, let's just initialize the data. So we have the texture, we have the we just can say we have the texture. Let the texture be something, and then in order to get it out of the scope, we can say texture equals, what did I call it? Texture equals texture, and then the width is the height. Since the texture is square, we can just use one value for the width and the height. And the data is the final data. So this should work. The width and the height. Do we actually need? Yeah, we need the cutout region, display region. And then we just say this is in pixel, because we need to convert this display region pixel into actual coordinates later on. But then we can just say, okay, let dp region px horizontal equals this. Oops. Yeah, that's not too great. And then we just say the let line points dot length is the vertical region, and then we can just say then we just say that we want the display region in pixel to be whatever we have done here. So this will technically always overwrite the latest file that we have loaded, but in this case we only load one file, so it doesn't matter. Display of dp right. So equals vec cannot find the path. Oh yeah, because this should not be a, this should be this. Display region cannot find the display region pixel. Pixel. Files, load files. We need to say data load files because we moved all of this in the data component. So undeclared module data. Did we not have this? We have the data. Maybe we'll say use data. Test bbox, yes. Basically need to load whatever bbox is coming in here, and then we load the files that belong into this bounding box. Get image bbox, probably in the data component, data module. Test b, again use the actual b bounding box. Cannot find value let line points. Oh, this is a bit unfortunate. We have the vertex buffer, but the vertex buffer does not belong here. We can say, okay, we actually want to display the region, and yes, we need to actually have a texture, because this doesn't work otherwise. So for anyone new to the chat, and what we're trying to do, basically, yeah. So this is currently where we are right now. So what we have is, just to demonstrate what we're doing, basically we have this file. We've generated this file. So this is loaded from my passport, come on. And we've loaded this from this height file. Unzip the file, and there we have this image. So what we're trying to do is load a region of the file and then display it using OpenGL. So in order to do this, we have generated points only inside of this region. And we have also have texture coordinates for these for these points. So what we're trying to do is map the x and y coordinates onto the screen. So we have the south coordinate, southwest coordinate, then we have the window. This is our actual window where we would have minimize, right? So this is the window that we're looking at, and all we're trying to do is get an extent of this texture to display on the screen. That's the goal for today. I think that should be doable. And last stream we only made the actual window appear, and so we can render to the screen. Let long points. So right, we need to have a vertex buffer. Texture, there we need to have a texture then, because otherwise this data would basically be lost, and this texture has a width and a height. So texture basically is this. We need to move this down, and this is just for data, saving the data to an image. This make BMP file, this just saves the data somewhere, but we don't save any data right now. So the data is not the final data. Then we need the display region pixel. So this is the actual image data. So this, maybe I should rename this to something more descriptive, but this is the whole image. And then this are only the points that we've loaded, and index buffer is important for later on, so we can connect the points and actually make some sense out of them. So this is the width of the whole image. Height the whole image. The cut out region we want to display. So in this region we have this region has a width of the region, and I'm sorry if my keyboard is fairly loud. I'm really sorry. But yeah, height of the region. I've tried putting a noise filter onto the microphone. I don't know if you can hear it, but these are basically the points that I drew in red. Red points. And then we have the index buffer. Indices to do later. Yeah, lots of people have. Vertex buffer. Alright, so we need to fill out all of these fields. We have the texture, we have the vertex buffer. Shouldn't we just say this is better. If we just say let app data let points. No, this doesn't. Yeah, we don't need this. We just say let these are the points that we want to reproject. To do reproject points. Because for those who are not familiar with these coordinate systems, what the goal of the what our problem is yeah. So this is, yeah, we have all this math. We have all this math already done in the conversion folder. Okay, so these are the functions. Again, the source is on GitHub. So this is the ellipsoid of the model of the Earth that we currently have. These are in meters. This is the ellipsoid. Yeah. So these are just the functions that do all of the math for reprojecting, and I've just taken them from an earlier project simply because I don't want to. First of all, I've just copied the implementation and rewrote it, but I've already tested it right here. So you can say that this thing is, for example, somewhere in Sydney. So these coordinates have to be the same. This coordinate is in latitude, longitude, and this coordinate is in meter. So in order to have it display in meter, we need to reproject it. So there are basically two functions for this: UTM xy to lon lat. I've always used lon lat to not confuse it with x and y. So longitude is x, latitude is y, vertical, and lon lat to UTM xy. So the reverse function of this, basically. So to have this somehow working, yeah. So this is where we are. We wanted to, we need to go through each, this is basically a vector of points, and we need to just reproject all of these points. We will do it with using multi-threading, but that's just later project. So we need to have this vertex buffer and index buffer. So here's where we just put the vertex buffer. So if we have this, we will just make the points to reproject, and here we need to put this here to do reproject points, and then we build the vertex buffer, then we build the display region. The index buffer is not important right now. Here we just fill out the vertex buffer that we created. Width and height are these two metrics. Technically you can calculate them from the vertex buffer every time, but yeah, it's not really. And these points are basically thrown away right here, so they just get stored in the vertex buffer, and then we can use fancy matrices and whatnot to reproject them. So texture, and then we also don't need this. So we just say let app data. So we will say, okay, app data equals app data where the texture equals sum, and then we just might, yeah, we build the display region. Then we say the texture is actually missing a field because it says the display region and then we say, okay, the app data, maybe we need to extend the app data later on. Maybe we want to render some sort of user interface, but I don't really think so. And then we say sum and texture. So that's basically filling this sort of struct. And here we just loop through all the files. Basically, we overwrite the latest position, but in this case, it does not matter. Laplon points. Yes. And this is not Laplon points, but this is basically points to reproject, points to reproject, display region, yes. So next one, did you mean box? No, I did not. Use renderer bbox. Did you mean no? Use renderer bbox. Next. Data get image. Function get image bbox. Yeah, I need to make the functions all public. Data pub load files, pub get necessary image files. So probably, yeah, I forgot the make this public. Always make functions public if you can, because you will run into these issues. Never mind. Window. No method read to end for type file. Yeah. Oh yeah, I need to put all of the use standard IO read. No method read to end. DP found usize expected U32 font user display region pixel horizontal as U32. Self.vertex buffer. Yeah. So we don't have the self.vertex buffer. So what we can say is if let sum tx equals self.texture. Yeah. So if we have a texture loaded, otherwise this will just clear. Again, here we redraw the screen, we clear the color and the depth to red, and then we just say, okay, if we have a app data, So if we have app data, and if this app data has a texture, which in our case is the case, but later on we want to maybe change this. So if let some texture equals app data texture. And if this texture is present, we know that we have a width, a height, the data, and the display region. So these are, if we have a texture, we have these other parts. Display region. So we can just say texture, the display region, and vertex buffer. Let's just do this and get it to compile, and then we will, where is it? Yeah. Texture dot display region. This should work. Display reassignment of immutable variable. App data. But app data is not initialized. App data user possibly. Why is this possibly uninitialized? Well, an easy way to deal with this is just to say, okay, we don't put this file up here, but we always override. This, and then we just say, okay, we just override this. Right. And this should work for the most part. Self.app data. Why don't you let me access self? It does. Oh, because I missed a semicolon or something somewhere. Self.app data, right. Let's see. This is a bit easier if we just load the file. Again, I do actually have a license copy of Sublime Text, but the problem with Sublime Text is that they just released version 3, and version 3 basically breaks all of the add-ons, so I switched to Emacs. So text editors is always just something that's load data. So where's window.rs? Window. Come on. Right. So this is easier to debug because there are functions in Emacs to do this, but I haven't found them yet. So we are basically missing some form of semicolon. This should be correct. Let display region, let texture, let app data. Okay. We don't need this. Oh, yeah. This should have fixed it, actually. And then we just close and restart. Again, it's done fairly well. Yes, that's something I don't really like, but if let some app data cannot move out of board context, of course. Probably this is something that I hope the new ergonomics thing does a bit better, because right now it doesn't automatically takes a reference because whatever. Let mute points. Yeah, we don't even need these points, so it's kind of useless to even have them in the first place. And then we just say overwrite the last state. So this should work, and let's see what we get. Probably a red window, because we don't put any of these right, but we don't get any problems, and then kill all SRTM, right? And because the close button doesn't work, so I have to kill it. Right. Now what we have is just to say, okay, implement the app window. We can just say, okay, here we have the main loop, and we redraw the screen. So what do we need to do? It does draw the screen, but the uniforms are currently wrong. So yeah, we need to this should not be a vertex buffer, but this should be a vertex buffer. No, this should be a texture, and then this should be a reference to a texture, so that we have access to the other metrics. So we can just move the thing here, texture dot display region dot vertex buffer texture, and then we just say right. This should still work. Oh boy. Oh yeah. Maybe with a reference. Yeah. So now what we need to do is calculate the metrics for the window. So what we have currently is, the thing is, we could, where we want to actually bring something on the screen. Let's see if let's see if we can actually get the dimensions. We can get the dimensions. Yes, X and Y. So the dimensions in pixel of the actual window that we currently have. Let dim width, dim height equal to frame the get dimensions. So this is the pixel width of the current window. So what we need to do is to say, okay, this delta east-west meter. Second thing is that we need to have a scale. We need to have a scale. Otherwise this won't work. And we need to have a dpi value. We need to have a scale and a dpi value. So, because now what we're trying to do to get accurately rendered pixels, what we need to do is transform the rectangle on the screen into something that is of real world size. So imagine if we would scale the window up like 100,000 times, it would be kilometers in size. So that's the dimensions in meter that we're trying to get, and then we can use the reproject the points into meters, and then like we did in the last thing, and then we just use these coordinates to project the meters into the window. So that's the task now. So what we need is we need a scale. What scale do we currently have? Scale U32. Let's just say F32. Maybe. And we need a dpi value. Yeah, we need a dpi value, dots per inch. So in order to dpi value of 32. The reason I'm taking floating point values is just because it's easier, because we don't have to cast anything and worry about like division and some other stuff. So we need a draw function, we need a main loop, because we want to let's just make this with a main. We have the scale, and then we have the tests dpi of 32 equals 72. 72 dpi is usually the thing to go with. Test scale, test dpi. So we say that we want to redraw the screen, and with the test scale and test dpi. So just to see that we're actually drawing on the screen, just to have some sort of thing. If frame length equals 60 frames per second, redraw the screen, Self UI update, we don't need that. If self UI needs redraw, push window event, run forever window event, events to push. Oh boy, this is not. First of all, I'm trying to get something out of wait events, but this might be able to reduce a problem, but it shouldn't. It probably won't affect this much. So self to draw, test scale, test DPI. So now we have all of the metrics to actually calculate this sort of stuff. So this is always in pixel. Window width meter equals to dimensions in pixel, and what is the dots per inch? So if we have 72 pixels, that would be 1 inch in the real world, and 1 inch is 2.54 cent. Well, what is 1 inch? dpi. Oh boy, why do I always get dots per inch? Later on we need a value of 300 dpi probably, which will make a 2.54. So this is the window width in meters. So we need to divide the pixel. So let's say we have the pixel dimensions with pixel divided by 2.54. That will give us the no, we will divide it by the DPI value and then take it, that will give us the value in inch, and then to get the centimeters out of the inch, we want to centimeter to inch. Let's say we have 800. Let's say we have an image that is 800 pixel. Then we divide it by 72, which will give us 11 inch. So we want to see what 11 inch is in centimeters. So we basically need to multiply it by 2.54. And then the same with the height. So this will give us the real width in centimeters. Of the window on the screen. Again, 72 dpi is usually the usual format for a monitor. Right, so now we have the centimeters. Now what we need to do is let window real scale meters equals horizontal width times window with centimeters times the scale. And then do we actually need this? We need these centimeters, but then we need to divide it by 100. Because there's 100 centimeters in meter, so we need to divide this by 100, yes. So this will give us the window of the projecting the window into the real world. So now what we need to do is we need to have the west and south coordinate of the window. Delta east west in meter. Delta east west in meter. So we can already say, okay, delta east west in meter is going to be the this is what we have. Window real scale horizontal, east west is horizontal, and then just to make sure that we have an F32, otherwise the OpenGL drivers always like to complain. In the real scale vertical. Right, now what we need to determine is where the west and south coordinate is. And then we need to reproject the points, and that should do it. Right, the west and south coordinate is west and south coordinate. This is very, very interesting because we did actually load the files. Then we load the image bbox. Now image bbox is not loaded anywhere. So we actually need to save this image bbox to somewhere, otherwise the data is lost. So in pixel, yes, oh, sorry, trying to, yeah, so image bounding box in let run coordinates. I think we imported the bbox. No, we did not. So we just use this. So we have the image bbox, and then we have the texture, and before we have the texture we insert the this should okay, there's only poll events now. Implementation for dim with px. Yeah, this should be casted as an F32 value, and then yeah, this should run fine. So now what we need to do is to have the west and south. So if we have the texture, we can say basically texture dot image bbox dot west and texture dot image bbox dot south. Now this won't work. This won't work because this is in lat long and this is in meters, so these are completely different values. So we need to reproject it, but the problem is that we reproject on every draw car, but in the end it's just two values, so it should go rather quickly. Yeah. The next thing is that we need a UTM zone. So if you look at the UTM projection, it's nice formulas and whatnot. But if you look at the UTM projection, is this actually better? Yeah, this is better. Here's a better image. So if this is basically the projection that we're trying to get. If we have, so the accuracy of the image is determined by this zone. So if we have this zone, this is like, I think here in Greenwich, is it 0? Yes, 0, then 6 degrees, 12 degrees, 18 degrees. And so if we are here, the image is not distorted. But if we were basically load this with the zone of 1, 2, 3, 4, 5, with the fifth zone, but we would have an image that is somewhere here, then it would be really, really distorted. Because remember, this is basically the UTM coordinate system, and it's only valid as long as you stay inside of this zone. As long as you stay here, everything is fine. But if you go across this, it starts to be a bit wonky. Now what people did is, usually if you go to let's say you have a map, so you realize that this is not actually the projection. This is the web Mercator projection, which does not have this scaling factor, but it's a bit inaccurate. So this is not the correct map projection for the world. There's no correct map projection, but this is not distorted. And the difference is roughly 4 centimeters per kilometer, and you know, it adds up. And we're trying to do the accurate projection first and then do the relative projection later on, because that's I think that's where's the code? Mercator project. Yeah, here's the code for the spherical Mercator. Yeah, this is the spherical pseudo Mercator. So this is not actually a Mercator projection in a good Mercator projection, but this is actually a fake Mercator projection, but it's good for like web maps, and lots of people use it, although it's not very accurate. But anyway, we need to say conversion and then conversion. Let's see what functions we do have. We have get UTM zone, which will be, this is not fairly important. Again, I've taken this from Yeah, basically this is the JavaScript library that I originally took the code from. So it's basically just one file, and this is the whole file that this is basically just copied. I don't actually am responsible for all of the math, but it gives the right results, so I use it because UTM and Web Mercator are the two projections that I mostly work in. So get UTM zone, longitude and latitude gives us the UTM zone that we need to use for the reprojection. Footpoint latitude is it's not important. It's just the calculates if you use the equator, right? So the equator is like 40,000 kilometers, and as you go up and up and up, basically the equator gets shorter and shorter and shorter until at the North Pole it's like zero length. So this just calculates I think this is the radius of the equator at a given y value, and it basically uses an ellipsoid, not a sphere. So yeah, this is some advanced math. So here we have ln lat to UTM xy. So this is ln lat to UTM xy. And yeah, you always need to have two coordinates in order to project something, because otherwise it would just be so this is why we have the southwest point. So in this case the x value is the west point. Oops. And then we have the y point, and then we need the ellipsoid, in which case we define we need the zone, and we should not recalculate the zone on every draw call, but rather, well, we technically need to get the UTM zone equals, we will do this later. Then we need to use the UTM zone, and then we need to use the ellipsoid, which is a reference to this ellipsoid. This is the standard ellipsoid for the model of the Earth. There are many ellipsoids, but so next thing we need to have is the UTM zone, which is the zone which is determined by this get UTM zone, and of course it needs the, well, it doesn't, yeah, we need to have the longitude and latitude. Technically we need to have the center of the region, which is, let's the center of the region that we're looking at. So if I hope you can all follow along. If you have questions, or just put them in the chat. When we have these file, come on. Right, so when we have this file, and what we are trying to do is to get here is basically the Earth, and here is our UTM region, and here we need to determine the UTM zone at the center where we're currently looking at, because if we just put this here, then the whole image maybe is somewhat distorted, and that's not what we want. So here is this is the region, let's say this is region 6 or something. So UTM zone is equals it UTM zone center display region X, and then we also need a Y, and this is fairly simple. We just take the north minus the south, plus the south and divide it by 2, which is texture image evokes.north plus texture image evokes.south divided by 2, texture image evokes, no, this should be, oh, whatever, dot east plus texture image evokes.west divided by 2, and then I mixed up X and Y. So what we can say, these are still in display region X, center display region Y, and then we have the UTM southwest, which again this lone lat to UTM XY gives us back, what does this give? Again an XY tuple. So we just can say dot 0 X and Y. Again, I'm not destructuring this tuple because here it doesn't make sense. But let's see if we can. No, we cannot. Conversion. Yeah, we don't have use conversion. Let's fix the issue. Yes, conversion. Not found in. Yes, it's found in conversion. Center the expected FC. Oh boy. I did once work with using F64 values. It doesn't really matter if you use double precision or single precision. In this case, it does really not matter. Texture image first expected F64. Oh yeah, as F64 as F64. This is why I usually do this sort of casting, so to make sure that, because OpenGL can only handle single precision, OpenGL does not like double precision at all. And there may be extensions where you can do double precision math, but for this purpose, double precision using reprojection on the graphics card is important, but the problem is that most drivers that I expect to get with this application are simply too old or outdated, or maybe it doesn't work. And usually, if you're not zooming into the, if if you have a scale, if the scale would be like 1000, so 1/1000, then this single precision, double precision thing might become an issue. But otherwise, if you have like, if this is 1 to over 40,000 or something, sort of like a you know, then it's really a minor issue. So this should work, and this should not actually give us any points because we do not have reprojected any points yet. So yeah, it's still red. It's still red. We do we have a UTM Southwest? Okay, so next thing that we need to do is before we need to reproject the points. And this is to say, okay, do we really want to yeah, the problem is that we need to use, first of all, need to reproject the points using the same UTM zone, of course, because otherwise it just doesn't work. Right, so to make this a bit easier, we say, okay, we have the texture, we have the display region. The display region should have a UTM zone attached to it, because it just, so we basically take all of this out and say, okay, do we really need this sort of stuff? We take this out and put it before we reproject the points. Before we reproject the points, we put it. Oh, come on. Image B box. Where do we have it? Image B box.north. So we only do the calculation of the UTM zone once we start up the renderer. Image bbox, center display, yeah. And then we just say the UTM zone is the UTM zone. So display region pixel. Again, if we will use WebMyCarta for reprojecting, we do not need a zone, because WebMyCarta is universal, so it's the same anywhere. And yeah. say points used on the final texture. We don't sample any of the texture yet, so this will probably be just it should be, first of all, we need to make a function in the data. So to say, just we project all the points in parallel. I hope we can do it in parallel. It would be really inefficient to not do this in parallel. Apart from we project points, then we need the definition of the points, which is a vertex buffer renderer make no. Yeah, we can actually look at the renderer what the points are. The definition of the points is basically this is the coordinate, and this is the texture coordinate that we will use. So this is somewhere in the region of 0 to 1, and then this is the coordinate, but and this is an xy field. So we project points, and this will take a mutable reference points to reproject. It's a mutable reference to this thing. So and then we just say like for row in points, row in points to reproject. This is just a simple thing for x, y, text, we don't text x, text y, and row. And then we conversion. Yeah, we also need the UTM zone. Conversion, what was it called? Lat lon lat to UTM x y, longitude, latitude, UTM zone, and a reference to Emacs, reference to conversion What's the ellipsoid? Yes, VGS 84 ellipsoid. And then we just say that new x new x new y equals this, and then we just set the we need to make this mutable, and then we just say x equals new x and y equals new y, and this should work, but I don't know if it will. Right, where do we need to clean up now? No. Window, where did we get the window? So points, so let's mute points to reproject, because I don't want to make a copy of the points, I just want to make a data reproject points, and then a mutable reference to the points to reproject and the UTM zone. Yeah, and I somehow managed to, yeah, this just happens sometimes. Keyword is very, 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 yeah, we need to use conversion. We need to texture. Yeah, right. We don't have the texture created yet, so we just say image bbox. UTM zone, yeah. Texture dot UTM zone. Texture dot display region dot UTM zone. Right. Yeah, I knew this would for row and for does this work? Yeah, it does work. I did not expect this. X as F64. Again, this is as F64. Maybe I should make this generic to have a well, I don't know if float-based traits are something that it's actually possible. As F32, as F32. Value assigned to X is never read. That is a problem. Yes. For reference mute, expected tuple on reference mute. So basically what we need to say is reference mute ref mute, because we don't want to take this out, but we want to put the data into there. Yeah. cannot cast mute F32. Yeah, we need to clone the data out of there and then just put the data back in. For reference mute for oh for you know what, just yes. So always be a bit sensitive to when the compiler says that this isn't used, because otherwise we would just, I think we would have cloned x into a new local variable and then overwritten this new local variable. And this should technically work, but it should also take a long time to start up. Yeah, it doesn't work. I don't know why yet, but yeah, it should work, but it doesn't. Shaders main rec. So we said we want 1.0, which is red green. We want actually to have green lines, green something on here, but it does not work. So what do? We use a proper debugger. Yeah, so if your problem is that the data here is too much to handle for any regular debugger, so there are possibly millions of points. The first thing to make sure is that we actually reproject the great, now my window is just that we actually reproject the points. That we reproject the points. We have the window, we have the texture. So let's try to debug this, because technically this should work, but it doesn't. So let's see if we are even drawing. And yeah. Yes, we are drawing. We are drawing. We are drawing way too much. Right? But we are drawing. So then let's see what we have. Then let's see what we have here. Let's see what we have here. Texture, and So let's see if we have some okay. Let's see what we have. We need to get the texture dot no. We don't need to do this here. What I now want to check is if the points to reproject is actually working correctly. Points to reproject at 0, and then we want to access the I. Right. Let's so these are 1,000,000 0 point This seems fair. I wish if I could use renderdoc to attach to running instance. Host name, fresh selected. No, we don't. File launch application, executable path. So executable path is target debug SRTM to image. Working directory doesn't matter. Allow full screen correct car stack launch. Right. OpenGL F12 print screen to capture 109 FPS. Non-core context in use. Oh yeah, but this should not matter. Pipeline state. Shader. Unbound shader view. Edit. No. Oh boy. Mesh output vs in vs out. No, we don't have a. I'm not terribly familiar with using vertex shader. Do you not get anything into the vertex shader? Why does this not have anything to do? Close. Trigger capture. No. Captures collected. Okay. GeoDraw arrays. So it does work. It does work. Let's just ignore this. So GeoDraw arrays. GeoDraw arrays, GeoTriangles first, count. We do push the vertices coordinate, GeoFloats 2, relative offset. See, here are the coordinates. Vertex shader out. Yeah, whatever. Highlight vertices. Index 0. Oh. So what we can see is that geoposition, the x coordinate is correct, but the y coordinate is just bonkers. I mean 28. So the y coordinate does not work correctly. And I think that's, yeah, I think this is, oh, I know why. See, this is why it's important to have a OpenGL debugger. Usually, I'm using the RenderDoc unstable release. You can get, RenderDoc is fairly easy to install. You just download or install. But this is also available for Windows, so it's a fairly good debugger for OpenGL. So without this, I wouldn't have known that the y coordinate is just, yeah, we don't have a graphic geometry shader. 28, this should be in the range of 0 to 1. This is also not correct. Here it's 5. But this shouldn't matter. This should not matter, actually. Even if we push these SRTM to image. So this is the back buffer. From mesh. Yeah. No problems detected. Yeah, except it doesn't show anything. So we have the coordinate coming in at 58100 . And then where can I look at the actual vertex shader view? Yeah, where's this delta? Where is the delta? Where can I see the? No, there's no spare V output. So textures, samplers, uniforms. Sorry. Come on. Uniforms. So here are our uniforms that we sent to the graphics card. So delta east west meter is completely, yeah. Delta east west meter is 3,000 meters. Southwest. Delta east west meters. South. If we look at the shader, so we get delta east west meter in at 3,000 something. 3,000 coordinate, and the coordinate dot x, it's the first thing, right? Dot x, coordinate dot x minus west. So let's just calculate this, because the numbers are technically correct, but we don't get the correct output now. So we have 3,386. That's our delta east-west. So first we have coordinate.x. Coordinate.x is yeah, we need to, yes, coordinate.x equals 581077.93, and then we sub the x coordinate. So then we cancel. So then we subtract the west coordinate, and we subtract the west coordinate, which is 571607.93, which is 9,470. 9,470. And then if we divide it by 3.3, 3,300, then we maybe get a weird result. Minus 1.0. Minus 1.0. Minus 1.0 plus x minus west divided by delta east west meter. I don't understand why it doesn't work. Let's just try to maybe the zoom is wrong, so let's not no, don't save this. No. Please. Right. So we don't need to have any of this if we can let RenderDoc do it for us. Yeah, so this part may be a bit boring because debugging is not a nice thing. I thought I could do this, but the problem is the actual values are completely okay. Maybe we just need a different scale. Oops. So what's the actual scale? Test scale is 10,000. Let's try 100 and 100,000. Right? Let's run it. We should, if we get some green points in some form or shape. No, we don't get any green points, which is great. I mean, and then we just trigger capture. So we have texture, we have the mesh, whoop, draw arrays. Where did I get to this? Yes, here, mesh output. So position equals minus 0.7, but it still is this always the case? Minus 0. Minus 0.3, minus 0. Thing. Alright. Minus 0.4, minus 0.0, 0.6. So the x values are okay. However, the y values are not. And the problem is still y is, so if we yeah, I cannot select any vertices because I don't have any in the view. 1.56 e plus 7. Yeah, well, maybe it's due to accuracy, but this should not, no, this should not be the case. Why do we have 2.7? 2.7. If we look at the frame draw arrays, and then what do we disable? Yeah, we disable the restart index. Shouldn't be there. Let's look at the working stuff. Right. Shaders. Vertex UTM area. So in this, maybe I should copy this just to be sure, but infloat lon, lat normal, east, west, south, the index UTM zone. Well, we don't need the UTM zone because we, this is exactly the same thing. But here we have lat lon lat to UTM zone, final x, divided by delta east, west, final y, minus south, converted. Longitude, latitude, UTM zone. Don't y plus false northing. The problem is not the x coordinate, it's the y coordinate. The y coordinate is not in the region. Sorry. just, but we are subtracting the south coordinate, right? Subtracting the south coordinate. Yeah, I don't see, if anybody sees the issue, just put them in the chat, but I currently don't. So, well, longitude, latitude, maybe it's this, because we don't have the correct precision, but I really doubt this. No, don't save, and again, kill this. So, just to be sure, but we let's see if this made any difference. Precision high P. No, it didn't. So west, south, west, south, and if we're binding these if we're binding these things, then we have west, x and y, right? So we're trying to do, okay, so first of all we need the scale. Then we need the first point. Well, we don't really have the first point, but oh, they do get. We can maybe use the center. Just use the center. So, as an example point, so this should, in the end, should be exactly 0 0.0, 0 0.0, I think. No, it shouldn't be. But offset. So this is UTM southwest at 0 minus wait. We're using west. No. This is wrong. I just realized it. This is completely wrong. What are we using for the west coordinate, right? We are using the is it wrong? So I said that we use the center as the west-south coordinate. Texture image bbox dot west south and the UTM zone. Yes, but this is using UTM, so no, this was actually correct. UTM west zone dot 0 minus the so the theoretical thing is if we subtract this 0 and then divide it by the scale. No, we are dividing it by the delta east-west meter window rear scale. This should still be 0. Window rear scale and horizontal. Let's just make sure that this is 0. Expected F64. Please just let this be 0. Because 0 divided by something is still 0. Yes. Scale is 100,000. If you're still watching, I don't know why. Come on. Why is this such a problem? Why is this such a problem? Delta east-west meter. But this is correct. This is the UTM southwest 0. UTM southwest 0. That's the difficult part, to actually get the coordinates into the window. Yes. Again, this is correct. But the first point, when we reproject the points, let's just say that we have the first point, and then we have points to reproject 0 and 0. Dot 0. Yes. We just want we don't want anything else. So the first point, and then I forgot this. So this is the west, and this is the south. This is the west. Come on, come on, come on. Okay. West, and this is the south. So let's just do the we have south. The west is okay, east-west is okay, probably. 1, 5, 6, 4, 1, 6, 0, 7, and minus 1, 5, 5, 3, 9, 0, 16, 102. This is this is basically impossible, is it? Yes, and 0.45. And then if we have the scale of 100,000, no, we don't divide by the scale, but we divide by the east-west extent, and the east-west extent is, well, we need to see what the east-west extent is. So does this frame get dimensions return xy or yx? So width, height, dim the x, dim Yes, this is correct. This is correct. So in meter, height in meter, these pixel horizontal and vertical. Yeah. Right. Let's see what we get. 100,000 is our scale. So 36,000 meter, and the height is 72,093 meters. So if we get the calculator and we don't divide this by the height, divided by 72,093.236. 93.236. Yes, you get 3.7. 3.7. The problem is that I do not understand what if we would divide by the other thing. 2.83, which would still not be correct, but I don't understand what I'm doing wrong, because I have the same thing for the width and the height. So when over centimeter, the most px times divided by dpi value times 2.54. Here scale horizontal times scale divided by 100. X, Y, lone lot, west, south, display region. Scale meter horizontal, scale meter vertical. Meter horizontal, east, west, vertical, north, south, then southwest. Right. And then we have south, which is the south coordinate. Yeah. If we really uniform float west, south, x minus west divided by delta east, west meter, y minus south, delta north, south meter, geo position With final x, y. Well, I do not final y. Why do we have this stuff? Why? Delta north, south, need. Does not make any sense. Because it worked, well, it worked when I first did this. Right. Let's just try to... This is just... Yeah, this is before I refactored all of this. This does not... Why do we have this layer iterate? Draw vertices, and then we have the current shader. Window width. Window state, uniforms, normal. I have bound the... See, no. This is for the user interface. Let's just uniforms, delta east west. So delta east west, north, south. Maybe it's because we have not calculated this B box east minus west, right? Then we have the look at to UTM box width equals we are calculating all of these. The other values are correct, but the width and the height are not. Save that. That was millimeter times 10. So we have the width, which is the width in pixel. Then we use the scale, the current scale. Then we use the X UTM, borrow the UTM, borrow the Y UTM. See, we don't have this look at X and Y because this is not the current system that we are working with. Divided by screen DPI. Yes, times 2.0 times 10. Yes, but if you multiply by 10 and then divide by 1000, it should be the same. Times scale, and then I divide by 2.0 times scale divided by, well, let's try. For some reason it worked. It's just not that I don't know why it worked. Right. Which should technically, yeah, it still doesn't do us any better. Because now so now what we have is Now what we have is that we have the... Why is the x coordinate correct? I do not understand. Wait. This is minus 1, 2, 1, and then minus 1, 2, minus 1, 2, 1. Isn't there a difference between FUTM basic? No. VUTM. There we go. So minus 1.0. No. We just have this divided by 2 now, but it doesn't solve the actual problem. Strange thing is this sort of falls northing because what is this thing? I could now continue the stream and try to get it working. I'm trying to get it working up until the next stream. I'm sorry that I couldn't show any cool stuff, but I will have it fixed until the next stream and then just tell you what the problem actually is. So, for those of you who watched, thank you. It doesn't always work out correctly as you... We should have a value of 0 to 1, but we don't, so I'm trying to get it fixed for the next stream, which is tomorrow at the same time probably. Right. Thank you for all who watched and hope you enjoyed it a bit. Thank you. Bye.